Algebra 1, 8.6, write and graph exponential decay functions. Exponential decay is a quantity that decreases by the same percent over equal time periods. So, example 1. Graph the function y equals 1/3 x, or 1/3 to the x, and identify its domain and range. Make a table of values. Again, since x is an exponent, we can put anything positive, negative, 0, a decimal in there. So our domain is all real numbers, or the R with 2 stems, because that is the math symbol for all real numbers. So we're going to start with 1/3 to the -2. That's the same as 3 squared, because we flip this over with the negative, so 3 over 1, and then we square that, so we get 3 squared, which is 9, so 9 goes right there. And then 1/3 to the -1, we flip it upside down, take it to the first power, so we just get 3. Then 1/3 to the 0 power is just 1, because anything to the 0th power is just 1. And then 1/3 to the 1 is just 1/3. And 1 over 3 squared is 1 over 3 squared, which is 1/9. So now we're going to plot the points. So -2, 9, -1, 3, 0, 1, 1, 1/3, 2, 1/9. So our graph looks like that. Step 3 was draw a smooth curve. From either the table or the graph, you can see that we're never going to get a negative number. So our range is all positive real numbers, or y is greater than 0. Either way that you want to write that. Okay, so graph y equals 2 times 1/3 x, and compare with the graph of y equals 1/3 to the x. So -2, we got 9, 3, 1, 1/3, and 1/9. Then for each of these, we're just doubling that, so 18, 6, 2, 2/3, and 2/9. So when we graph this, our first one is going to be 9, 3, 1, just like that again. And then our new one is going to be way off the chart. Then 6, and then 2, and then 2/3 and 2/9. So it's going to be a little bit higher than our previous one. So because the y values for y equals 2 times 1/3 to the x are twice the corresponding values for y equals 1/3 to the x, the graph of 2 times 1/3 to the x is a vertical stretch of the graph of y equals 1/3 to the x. now you have a checkpoint. So pause the video and go ahead and do that. Okay, so tell whether the graph represents exponential growth or decay. Then write a rule for the function. Since it goes down from left to right, we know that it is exponential decay. So the y-intercept is 5. So A is 5. We find the value of B by using the point 1, 1, and A equals 5. So for y we have 1, and for x we have 1, because our point is 1, 1. And for A we have 5. So then we have 1 equals 5 times b to the first. We divide by 5. And we get b to the first, or just b, is equal to 1/5. So our function rule is y equals 5 times 1/5 to the x. Or if we want to use a decimal, y equals 5 times 0.2 to the x. Either one is acceptable. So our exponential growth and decay graphs look just like this. So our exponential growth goes up from left to right, and our exponential decay goes down from left to right. So for exponential decay, just like exponential growth, A is the initial amount. R is the decay rate instead of the growth rate. 1 minus R is the decay factor. And T is the time period. So now we have example 4. The population of a city decreased from 1995 to 2003 by 1.5% annually. In 1995, there were about 357,000 people living in the city. Write a function that models the city's population since 2005. Then find the population in 2003. Okay, so first of all, we need to know what our initial value is. So, starting off, originally we had 357,000 people living in the city. So, the initial value is going to be 357, because we're talking about people in thousands. So, we're going to ignore the 1,000. And then our decay rate is our 1.5%, which as a decimal is 0.015. Now we are going to substitute 357 for A and 0.015 for R. So 357, 0.015, just like that. Now we simplify. So 357 times 0.985 to the t power. So that's our equation. To find the population in 2003, which is 8 years after 1995, we are going to substitute in 8 for t. So 357 times 0.985 to the 8th. Substituting in 8 for t. So our population we get is 316.3-ish. So the city's population is going to be 316,300. As we put the thousands back in. Okay. Now you have 2 more checkpoints. So pause the video and complete those.